new, what? Well, on that problem, it looks like this. 7 to the negative 5th times 7 to the negative 1st times 7 to the 6th. So the answer to that I wanted you to give was this, 7 to the 0 power. I didn't expect you to say equals 1. I don't think I've ever done that this year. Give you something that you haven't seen before. Alright, so anything to the 0 power is 1. That is the exponent rule that we're using first today. And then we're going to be doing more power to the power. So more multiplying and more complicated situations with that. The thing that you have to be careful about here is the only piece that is equal to 1 is what the exponent is attached to. So if you have parentheses and the 0 on the outside, everything in the parentheses turns into 1. But if that 0 is only attached to one thing, that one thing is the only thing that turns into 1. So here, d to the 0 power is 1. Just 1. 7 to the 0 power is just 1. Here, this is m to the 2 plus 5 plus negative 7. So that's m to the 0 power, which is... Now careful here. What is the 0 attached to? Just the x. So this 3 is not affected by that 0 exponent. This is just 3 times, and then this piece is 1. So 3 times 1 is 3. It is very, very common in this situation for students to just be like, 1, and then you get it wrong because you didn't pay attention to that 3 being in front of it. So you have to be careful about that. You guys did give me homework yesterday. So the homework that you gave me yesterday, I just want to make sure that you... I need Desmos real quick. On Desmos, you can do roots other than square roots. So yesterday we needed the 5th root, and I knew I'd done it before, and I couldn't remember where it was. And it's under functions, and then miscellaneous. You have this little root guy here. So I think what we were doing was like the 5th root, the 5th root of 16 squared. So it's just over here, right here. So we had 5th root, under here we had 16, and then squared. And that's how that would look. So it's under function. The one thing that Desmos can't do is turn those, like you can't turn those decimals into fractions. Like yesterday we had the equivalent of 1/8 in decimal form, and that's something that like Mr. Schaefer and I will write down. Be like, hey Desmos, fix this for our kids. Because that's the one thing that the 84 is, like you guys are very good at, just, you know, math, enter, that Desmos isn't going to do for you. If you have 0.125, you can't change it into 1/8. You just kind of have to guess and test until you figure out which fraction it is. If it is if on the OST, if you're like filling in a blank, like what's the answer, and you were going to say like the answer is x to the 0.125, they will take that as correct. It's just trying to be able to match that up with multiple choice. Okay, so anything to the 0 is 1. Okay. Now we're going to do, so this is really not a new rule. I'm not even going to write it up on the board. This is a rule that goes with this. More power to a power. If we're doing power to a power, we multiply our exponents. And that holds for if we have more than one thing inside our parentheses. So here we have 5 and x cubed in our parentheses. They're both being squared. So here's how I would deal with this. This is kind of distributed. It's kind of the way we like to think of it. So this happens 2 times, but it also means that this 2 applies to the 5 and it applies to the x cubed. So this is going to be 5 squared times x cubed squared. This kind of thing only works if it's all multiplication. All of these are all multiplication. When we study for the OST and we have something that's like x plus 2 quantity squared, that's going to be different because of the plus of them. So I guess I missed our example in the text box up here. So what did we get for our final answer here? What's 5 squared? 25. And x to what power? 3 times 2 is 6. It's really common to do 5 squared is 10. So make sure if that's something that, like, if that was your first thought, just double check it in the calculator. All right, let's go back to this example. N cubed b. That's really b to the first. So I'm going to slide a 1 in there as my exponent. And then when I bring this 4 in, it's going to multiply. So I'm going to do the middle step where I do n to the 3 times 4, b to the 1 times 4. And then 3 times 4 is 12, and 1 times 4 is 4. That's done. So really our 2 rules that we're using a ton here are power to a power. So if you have outside the parentheses, you're multiplying in. And then if everything's on the same level and all your bases are just multiplied together, that's what you have. All right, more examples. We're bringing this 3 in. It's going to be an exponent on the 7. It's going to multiply with the 9. 7 to the 3rd. M to the 9 times 3. Write down the middle steps. I really think the repetition of writing down the middle steps is going to make these rules stick with you. If you just write down the answers when I put the answers on the board, next Tuesday when we take the quiz, you're going to be like, I don't know when to multiply and I don't know when to add. And at that point, we can't help you. I mean, we still will help you. We just can't help you on the board. What's 7 to the 3rd? 343. And what's my exponent on my m? Awesome. Done and done. Bring your 4 in. Multiply it with your 6 and your 2. N to the 6 times 4. X to the 2 times 4. Write the middle step. Write the operation that you're doing. Repetition is what makes things go into long-term memory. And honestly, I've been doing exponent rules for lots and lots of years. Not that I'm old, Gabe. Don't call me old. I did the middle step on every problem. I did multiple middle steps on some of the problems that are student asking. Bless you. What's 6 times 4? 2 times 4? And we can't do any more than that. We don't know what n is, we don't know what x is, so we can't raise those to any powers. Alright, same thing. So 3 squared, g to the 4 times 2. 9 g. Lovely. Do a couple more. Now we're going to mix our exponent rules all up. If you choose to work ahead, that's great, because all of the math here is easy, but it's easy to get confused too. So make sure if you're working ahead, you're just glancing up and double checking your work. Power to a power, we multiply. So when I bring this 18 in, I'm going to multiply it with the 1/2. So it's going to be n to the 1/2 times 18. Let's just finish up with that, and then we'll deal with this other nastiness. So what's 1/2 of 18? 9, yeah. Multiplying by 1/2 is the same as dividing by 2. So that whole first guy, n to the 1/2 to the 18th power, just turns into n to the 9th. All right, let's see what this other set of parentheses, and then we'll multiply. This 0 applies to everything in the parentheses. What's anything and everything to the 0 power? 1. And n to the 9th times 1 is just n to the 9th. So this is a situation where it looks like it's going to be a really nasty problem, and it's pretty easy once you do the baby steps. Okay, 2. Let's just see what's our x here. This is a power to a power situation, and I always look for that like kind of difference in placement, like difference in almost like altitude. Power to a power, you're going to have one that's on top of the other, and that's how you know to multiply. If everything's on the same level, that's when you add. I think that's really helpful. So here, this is going to be x to the -2 times -2. And what's -2 times -2? 4. All right, that's all I can do with that x right now. So I'm going to leave it for a minute and deal with this other mess. This 4 needs to come in and be an exponent on everything. The 3, the x, and the 5. So I'm going to have 3 to the 4th. X, what's the exponent on x right now? 1, so you can write it as 1 times 4, or just x to the 4th. And then y to the 5 times 4. And now everything is on the same level. Questions about that stuff? Lots of details, which is what makes exponent rules tricky. There are a lot of details. That's it. So what's 3 to the 4th? 81. I'm going to bring down to x to the 4th, and y to the 5 times 4 is going to be y to the 20th. The last step is to clean this up. So do I have any like variables right now? The x's. And if everything is on the same level, what am I going to do with those variables? What am I going to do with those exponents? Add them, yep. So I'm going to bring my 81 and put it in front. If it helps you to do this stuff and put them next to each other, you can. You're going to add that 4 plus 4. Try the next 2.